Hello everyone and welcome to this presentation. My name is Ruldan Sumikad and this is about MANCOVA, Perform, and JASP application and Jamovie application. Now these both application are free statistical software which we can download for free in order for us to run any statistical analysis. Now, this presentation is just simply showcasing the different features that we can have in performing MANCOVA in both JASP and Jamovie application. Sit back and let's begin now the presentation. So, what I would like to present this time is that how to perform a MANCOVA multivariate analysis of variance using two free software which is available online, which is you can download it for free, which is the JASP application and the Jamovie. So let me begin by introducing you the data. Of course, in order for us to perform, we have to also consider our data set. So let me start by introducing you the data. So you notice that I have a data that is written or presented using or prepared in Excel format or Excel file format. So this is the data that I have, which is about containing three variables, which is the training, melodic, and rhythmic. So this type of data set, the training was classified whether it is a classical musician or just musician. And then melodic, this pertains that the musician has a better result on test of melodic dictation. And then the rhythmic also, the musician has a better result in a test of rhythmic dictation. Okay, so the data looks like this. This is just a fictitious data, and if you're going to look at it, this is where the source of the data. Which, if I haven't mistaken, this is a data that was actually used in a specific study. But I cannot download it because I need to perform any subscription. But nonetheless, I just like you to understand that this data is taken from this source. Okay, so and then at the same time, I need you to understand that this data set, I also translated it and come up its version using the SAV file format. Why? Because the Jamovie application accepts the Excel file format. However, the JAS application do not. So, but both of these application accepts if we're going to use the SAV file format. So that's why I prepared also the data in SAV format so that I can just easily present it during the presentation. Now, let us begin by, of course, I would like to start with the Jamovie application. So I have it already installed in my laptop, which you know that this is very important that you have installed it first in your desktop or laptop. Okay, let's open it. All right. While waiting, okay. So Jamovie is a little bit heavier application, so we just have to take a little bit. And now we have here and we are present down to this one. So we can just click here the burger icon on this side of our display. Click this one and then click open. So just click browse. So we will be able to browse our data. So you can see here I have here the MANOVA fictitious data that we're going to use. And then this is the demo. This is equivalent to the SAV file format of this of the MANOVA. So like I said, I'm just going to use the SAV format as the same file format is also accepted using the JASP application. So click that one so that it will be uploaded in the our application. So you see, we have already the training, the melodic, and rhythmic. So if you notice, we have 12 samples of classical musicians, and as much as there are also 12 jazz musicians. And these are their scores pertaining to the melodic and rhythmic uh, dictation tests. Okay, so next what we're going to do is we click ANOVA, this one. Click this one, and you see there is one-way ANOVA, repeated measures of ANOVA, ANCOVA, and MANCOVA. But like I said, in this presentation, I am just going to focus with MANCOVA. So we will click this one here, and this is what will appear. So you see, by default, there are four multivariate statistics that was we have here. We have the Pelias trace, the Wilks lambda, the Hotel links trace, and the Royce larger root. So we have the four. So we'll just leave it as it is already pre-selected, all four of them. We just have to leave it as it is. And then you know that in our display there is dependent variables and we have factors. So in the dependent variables, we are just going to drag and drop our dependent variables in this tests. So which is actually the melodic and the rhythmic. Okay, we will just have it here. Actually, the other option is we just have to drag and drop. Okay, like this. So we may highlight both and then drag and drop. So we place it under dependent variable. And likewise, our factor is we drop and drag it in here. So we have. So the good thing about this application is that it automatically generates the result. And for the movie, you see there is also univariate test results that is provided. And we know univariates only correlates the two variables at a time. But however, this one here, the multivariate test, the MANCOVA that we perform, actually it correlates all three variables simultaneously. So we have here the result. So before I'll introduce to you this result here, you might be wondering there is a covariate. Covariate also is another options that we can perform in this particular application in the event that we wanted to also test and look for any possible factors that may affect the result, any other variables that may influence our tests, and that results to the covariance. But for now, we don't have it here, so we'll just focus in this area, which is the dependent variables and the training. The factors. Okay, so we have here the result. But before that, there are also other things that we can also see in our display. There is assumption checks like the box M test. Okay, if we click that one, this is its result. By the way, the box M test, it helps us um, test the homogeneity of covariance matrix test. This is the results when to test homogeneity of covariance. And if you notice, this is our result here with a p-value of 0.145. Upon me research, when we have this kind of result, p-value, this simply suggests that we fail to reject a null hypothesis, implying that, by the way, in test statistics like this or in a test like this, the null hypothesis suggests that the data follows a homogeneity. Okay, so as we fail to reject the null hypothesis in here, it simply means suggests that the data is there is homogeneity in terms of our data set. Now, next that we have here is also the Shapiro-Wilk test. We know very well that Shapiro-Wilk test is used to test for normality, to test that whether the distribution of the data follows a normal distribution, and that this is, by the way, Shapiro-Wilk is intended when we test normality of any distribution with sample sizes of less than 1,000. Okay, as there is also the Kolmogorov, which is the alternative one when in cases that we have distribution sample size of more than 1,000. So in here, as you can see, the p-value is 0.634. This simply suggests that we fail to reject the null hypothesis. And which by when we perform a test hypothesis, when we test for normality, the null hypothesis would always suggest that the data is normal. So in this result, the 0.63 suggesting that we fail to reject the hypothesis simply implies that the data is follows a normal distribution. Okay, with this one. So with respect to our data, data set here, it follows a normal distribution. Okay, and then the next one is the QQ plus multivariate normality. What is QQ plus normality? Okay, so you notice that in terms of the QQ plus assessing multivariate normality, this suggests that this result we have here suggests that uh, as the dot departs from the straight line linearity wise, it suggests that the multivariate normality test was, the data do not possess a normal distribution. All right. That is the function of the QQ plot of multivariate normality. So as the dots here forms a straight line, suggests that there is normality when it comes to our multivariate. And then, but if it doesn't, then that means to say the data do not possess a normal distribution. Now, let us go back to the result of our MANCOVA because this is basically the purpose of this presentation. So you notice that there were four default multivariate statistics performing once we perform MANCOVA. We have the Pillai's trace, the Wilks lambda, Hotelling's trace, the Roy's largest root. That upon my research, you notice that the p-value for all four multivariate test here resulted the same value. But the question is, which of these four is are we going to use? If you notice, in terms of the Jamovie application, all these four was already pre-selected whenever we ran MANCOVA. But upon my research, among these four, they have their own strength as to when to use them. But as to what is by default suggested to be the basis when we perform MANCOVA is the Pillai's trace. Why? Because of its robustness in terms of the robustness of this test when it comes to test of normality. So it's like it doesn't depend so much on the idea that the data should possess a normal distribution and things like that in order for us to rely on its result. Okay, that's why among the four, what's highly suggested to be used is the Pillai's trace. So you see, the result of our test here for MANCOVA, all four have resulted to the same result, which is the 0.45. So our conventional alpha, especially for social science researchers, is 0.05. So with respect to the test of null hypothesis here, since our p-value is less than our conventional alpha for social science researchers, then we opted to reject the null hypothesis, implying that there is a significant difference when it comes to the jazz musician and classical musician with respect to melodic and the rhythmic test. So this is what the data suggests now. As a result, that we have to reject the null hypothesis. So basically, that's all about how we reject or how we perform and run MANCOVA using a Jamovie application. All right. Now, I would like to proceed and also perform the same. So, this is quite a comparison, a not comparison, but also the attempt of running the same test statistics, but this time with another software or another statistical application, which is the JASP application. So, let us try to minimize this for the meantime, and then let us try to open the other application, which is the JASP application, which is, by the way, another free software. So we have it here. You notice it runs smoothly. As I understand, it may have been to be more user friendly compared to the Jamovie application. So we, at the same time, okay, let me just have it in full screen. We will also click the same burger icon, which is found in this side of our display. Click the same one, this one, and then open application. Since I have already run this several times, I have already the file in my recent file. So I'll just click demo. Because by the way, like I said, the JAS application do not um, I mean, Excel file is not being read when I have it in JASP application. So that's why I saved the file in the ASB format. So the same display, we have here the training, then we have the melodic and then the rhythmic data pertaining to our um, the data set that we have. And again, we click the same tab, which is the ANOVA, which would also lead us to the different different test statistics. We have ANOVA, repeated measures of ANOVA, ANCOVA, and MANCOVA, which is very much the same with our Jamovi application. So again, let's click MANOVA at the same time. So if you notice in our display here, there is no covariance. So I think this is the thing that one major difference that JAS and Jamovi have. That the JAS application, when you click the MANCOVA, it does not show any backs for covariance. Okay, I already explained to you what is the purpose of the covariates. Now, the same manner, we will drag and drop our dependent variable accordingly to where they're supposed to be. Okay, we drop it here, and then we have our training drop in our fixed factor as our independent variable. So, likewise, the Mancova, they have different display of result. So, if you notice, by default, also for the by default in our JASP application, Pillai's test was presented. And I already said it earlier that perhaps this is because its robustness into when it comes to normality and things like that when with respect to our data set. So here you go. The result's still the same. It is 0.047, which the same with the Jamubi result rejects the null hypothesis, implying now that the data that the two groups, the classical musician and the jazz musician, with respect to the with respect to melodic and rhythmic, has a significantly have different needs. Okay, as we rejected the null hypothesis, and likewise, we can also make and have an additional options here. So if we would like to also include the three other multivariate tests, we just click here the additional, and then you go. We have the Wilkes, and then the Hotelling's Lil Way, the Low Way, and then we have the Roy. So it's basically just the same with what the Jamovi application can perform. So if you notice here, there is also the homogeneity of covariance matrices, which I already explained in the Jamovi application, which also have the same value. Then multivariate normality, the QQ plot, you will also get the same result like this one. By the way, the multivariate normality in here, the Jamovi application showcases the diagram, but in here it provides us the value. So which is 0.6394. By the way, both the with respect to the assumption check, um, the basis for testing here is that still the 0.05, but our null hypothesis here suggests when it comes to we have a homogeneity in terms of the box M plus, we reject we fail to reject null hypothesis implying that there is homogeneity. And then when it comes to the test of normality also, the 0.634 suggests also that the data is normal because the we fail to reject null hypothesis that states that the data possesses a normal distribution. And then we also have here the ANOVA table like this. So it will also provide us a result such as like this, with, which means to say this is equivalent to the univariate test with the Jamovi application, which you notice the results are just the same. However, there is one more icon that we can click here, test that we can perform also using the JAS application, which is the this one. When we click this is its result. Now, you notice that as we click the maximum P ratio, this icon, this is our result as it was added additional column in our multivariate test, the Pillai's test and the Wilkes, the Hotelling slowly, and then the Royce test, this one, the last column that you can see. You see the result here is 2.551, 2.5, it's just all the same. Now, what is the purpose of this one? This is just another way of interpreting our test, our null hypothesis test, aside from using the p-value. So you know that, how do we interpret this? This suggests that, example, that if your VSMPR, it suggests that it indicates the data is more likely under under the alternative hypothesis. If the result is equal to 1, for example, our VSMPR is equal to 1, is equal to 1 rather, it suggests that it doesn't mean that it's equal, but rather the maximum P ratio test only tells that it cannot provide us a more precise basis in terms of whether it is lower bound or upper bound between upper bound and lower bound of the Bayer's factor. And then in the event that our result here, the VSPMPR is less than 1, then that suggests that our result is under the null hypothesis, which is just exactly the same or has suggests the same result with our multivariates test, like the Pillai's test that suggests that we have to reject the null hypothesis, which means to say we are more geared towards the alternative hypothesis as the value of our P here for the Pillai's test is 0.047, which means to say we have to reject the null hypothesis. So that means we are under the alternative hypothesis. So see, the VSMPR and the Bely's test results to the same decision, which is to have the alternative hypothesis and reject the null hypothesis. And so far, those were the things that I can share with you. And as I look into the two application, trying to differentiate. So if you can see, I tried to show a multi-screen here in terms of the result. The two has actually just the same result. Okay, so we have here the result for the movie application. All four was just presented in one table. However, in the JASP application, it was separately presented because for the movie, all four multivariate tests were picked as pre selected test statistics whenever you click MANCOVA. However, for using the JASP application, the pre-selected MANCOVA test, whenever you click MANCOVA, is just the Pillai's test. You just have to perform additional options there if you wanted to add the three other more. Okay, but nonetheless, they have the same result. Jamobi has the univariate test result also, and you can also do that one in using the Jamovi, the just application, which is this one, as you perform the ANOVA. So, which is just precisely just the same. Okay, as a result, you have this value here, and then in terms of assumption, you can also do the box homogeneity of covariance matrix test, Shapiro-Wilk multivariate normality test, also for Jamovi, and we have it also in our JASP application. And then another thing that we may also observe here is the Jamovi application provides us this diagram, but we don't have any diagram or graphical presentation in JASP application. That unless is maybe if we're going to use its graph function. Okay, so to put it all together, this is precisely just a quick show or a quick run of MANCOVA and the two very useful free statistical software that we can use when it comes to running statistical analysis, especially for our researches and among other purposes that we wanted to run a statistical data analysis. So again, if you have questions, you may leave your comments and questions in this video, and let me return back to you whenever I can. Thank you and bye everyone.